Starting on page 385, solving radical equations. Solving radical equations, all right? First of all, let's look at the definition of a radical equation. A radical equation is an equation that has a variable in a radicand or has a variable with a rational exponent. So in order for it to be considered a radical equation, it doesn't just have to have a square root in it. Specifically, the variable has to be affected by the square root, meaning the variable has to be within the root itself, or it has to have a fractional exponent, meaning it would put it in a root if you did it. All right? When you're solving a radical equation, the first one is with index of 2, meaning a square root. Your goal is to get that root by itself and then to get rid of the root altogether and then solve for x. So when you're looking at this, you want to get that radical completely by itself. In order to do that, you are going to have to subtract that 2 from both sides. So the first thing we're going to do here is take that 2, and we are left with the square root of 3x minus 2 equals 4. Now the way you get rid of a radical is you raise it to whatever the index is. The index here is a 2 square root, so we are going to raise that to the second power, all right? So in order to get rid of the radical, we have to raise it to the second power, but equations say whatever you do to one side, you have to do to the other. So I am also going to raise the other side to the second power, all right? On that left-hand side, really what happens is my radical and my exponent cancel each other out, and I am left with just that 3x minus 2. On the right-hand side, I need to actually do the square. 4 squared is 16. And now I have a rather simple equation to solve. So I will take that equation and I will just solve for it. Add 2 to both sides. I have 3x equals 18. And then divide by 3. I get x equals 6. All right? Now, it's important to check these. All right? We'll talk about when you must check them. I'm going to show you how to check them, but there are times when you have to, so we're going to go ahead and walk through the process. To check it, you do it like any other equation. You plug it in. So I'm going to say 2 plus the square root of 3 times 6 minus 2 equals 6. 18 minus 2. Right, plug it in. Yes, it works. Yes, it is a solution. Easy enough. So on this one, they do not have a root. They have a rational exponent. All right, so on this one, you're still getting it by itself. Divide both sides by whatever might be with it, or if there's an addition or subtraction outside of it, do that. Your goal is to get it to the first power, so raise it to the reciprocal. Raise both sides to that. On the left-hand side, it will cancel. You're left with what's inside. On the right-hand side, you may have to rewrite it as a radical, square root cubed. So that would be 5 cubed, 125, add your 2, and you have solved it. And then, of course, check it by just plugging it in. You should have gotten 6 here. Divide by 2 first, and then you're going to raise both sides to the 2/3. That's the cubed root of 27 squared. Cubed root of 27 is 3, squared is 9. Subtract 3 from 9, you get 6. Plug it back in, you'll see that it works. Top page 387. Checking for extraneous solutions. Extraneous solutions. Right, the term extraneous solutions just means it will work when you solve this, but when you plug it back in, it will not work, okay? Because we are talking about principal roots, and so we're not talking about the negative root or something. We're talking about the principal root here. So we are going to solve it exactly the same way. We are going to start by getting our radical by itself. What you notice on this one, however, is that there is an x on the right-hand side. So I have an x minus 3 under the root on the left, and I have an x minus 5 now on the right. My radical is by itself, but I am going to have to FOIL when I do this squaring, all right? So when I square on the left, I'm still going to cancel out that radical, and I'm going to get just the x minus 3. But when I square on the right, I'm actually doing this process, x minus 5, x minus 5, right? And so I'll get x squared minus 10x plus 25 when I do that. All right? You don't just square the x and the 5. You FOIL. So you get x squared minus 5x plus 25. All right? So we will get x squared minus 10x plus 25 here. All right? Now, here we have to solve a quadratic. And we have to solve it by one of the methods we learned. We have to solve it by factoring, by the quadratic formula, or by completing the square. I will say I always look for factoring first. So what I'm going to do is I'm going to get everything to one side so it is equal to 0. And I also will leave it on the side where my x squared is positive. All right, so for this particular one, what I would do here is I would subtract my x and add my 3. So I have to do that on both sides. Subtract your x, add your 3. So on the left, I have that 0. And on the right, I have x squared minus my 11x plus 28. So now I just need factors of 28 that add to 11. What are factors of 28 that add to 11? All right, so x minus 4, x minus 7. X minus 4, x minus 7. Which means I need to set each one of those equal to 0. X minus 4 equals 0. X minus 7 equals 0. My answers will be 4 and 7, right? 4 and 7. I need to check these. Anytime you have an x outside of the radical as well, you must check your answers, okay? So I'm going to plug them back in. I'm going to go back to my original equation, and I'm going to plug in my 4 and 7. So I'm going to say the square root of 4 minus 3 plus 5 equals 4. All right, and then I'm going to say the square root of 7 minus 3 plus 5 equals 7. All right, for this top one here, 4 minus 3 is 1, the square root of 1 plus 5. Square root of 1 is 1 plus 5 equals 4. Now here's what some people tend to do. Well, the square root of 1 could also be negative 1. All right, that is true if I had x equals the square root, right? But I don't. It's all numbers. I'm just plugging in numbers. So when you plug it back in, you're basically doing order of operations. An order of operations for a square root always assumes the principal root, right? So you can't assume the negative root here. You can't say, oh, well, the square root of 1 is positive 1 or negative 1. That is only when x squared equals 1, okay? When x squared equals 1, you have to consider positive and negative because you have a variable there. We don't have a variable anywhere in this problem. So 1 plus 5 does not equal 4. That means 4 is not a solution. All right, 7 minus 3, that is square root of 4 plus 5. That is 2 plus 5, which does equal 7. So yes, my answer here is x equals 7, and that is my only answer. So for this one, yeah, what you basically want to do is you're going to want to get one on one side and one on the other. And then I would convert these to fractional exponents personally. All right, because your goal is to get it to 1. So we have, if I were to move this over, right, then I'm going to have 2x plus 1 to the 0.5 equals 3x plus 4 to the 0.25, all right? Now, here's the deal. They don't show it as fractional exponents here, and actually in the book they never change it to fractional exponents. But I don't know that you would recognize quite as easily what you need to do here unless you convert it to fractional exponents. If you recognize it, then perfectly fine to do so. But you're trying to get both of these to a whole number, some number that you can easily get rid of. You can't easily get rid of a fraction when you have a binomial taken to it, okay? And so the way I would do this is I would rewrite these as fractions, all right? 0.5 as a fraction is 1/2, right? 0.5 is 5 over 10. 5 over 10 is 1/2. 0.25 is a fraction is 1/4. 0.25 over 100. That's what that means. Reduce it, you get 1/4. So I would write both of these to fractions, all right? And your goal is that they're both whole numbers. They're no longer rational exponents. So what you have to do is you have to raise both sides to the common denominator, all right? So you are going to look at this 1/2 and this 1/4, and you're going to say, what's my common denominator between 1/2 and 1/4? What is it?
1/4.
It's 4, right? My denominator is 4. So I am going to raise both sides to the common denominator of 4. I'm going to raise this to a 4, and I'm going to raise this side to a 4. I have to raise them to the same number. Whatever I do to one side, I have to do to the other. All right? Then at this point, I can look at just my properties of exponents. I have a power to a power. What do I do with those when I have a power to a power?
You multiply?
I multiply them. So 1/2 times 4 gives me what?
2.
2. So 1/2 times 4 is what I've done here. So I get 2x plus 1 squared. All right, that's on that side. All right, let's look at the right-hand side. On the right-hand side, I have 1/4 to the 4. So I have 1/4 times 4. That's actually just going to be to the first power. So I just have 3x plus 4 there. All right, now I just need to solve it. On the left-hand side, I have to FOIL. It is a binomial, a group raised to a power. So I actually have to FOIL this. On the left-hand side, I don't have to do anything right now. I mean, on the right-hand side. So foiling it, I'm going to get 4x squared plus 4x plus 1 when I FOIL this guy. And on the right, I have 3x plus 4. Once again, my goal is to do it the easiest way possible. So I need to move everything over to make it equal to 0 and then see if I can factor it. All right, if you can factor it, that's always the easiest way. So we will factor it first. Subtract your 3x, subtract your 4. I will get 4x squared plus x minus 3 equals 0. All right, a couple ways to factor this. You can multiply the first and the last. Y'all remember that? Yes? And so if I multiply the first and the last, I'm going to get 4 times 3 is going to give me that 12, negative 12 specifically. Factors of negative 12 that add to give me 1. What is that going to be? Positive 4, negative 3, right? So I'm going to say 4x squared plus 4x minus 3x minus 3 equals 0. What's my method to solving here? Grouping, right? So I'm going to group these. If I group after a negative, change that last sign. What can come out of the first group?
4x.
So I have 4x, x plus 1. What can come out of the second group? X plus 1. So my factoring looks like this. 4x minus 3, x plus 1. So if I set this equal to 0, I will get x equals 3/4. And if I set this equal to 0, I will get x equals negative 1. All right, negative 1. Now, this is what I have. What do I need to do with those? I need to check for extraneous solutions. It actually told you right here in the instructions. All right, so when you check for extraneous solutions here, you need to take your original problem and you need to plug it in. Plug it in. So I'm going to try to grab him. I'm going to do it on the next page for the sake of space. All right. So for this, I don't want to do that. So I'm going to take this and I'm going to look at my two problems that I had here. All right, so let's check negative 1. We're going to do the same exact thing. It just won't give us fractions this time. 2 times negative 1 plus 1 to the 1/2 minus 3 times negative 1 plus 4 to the 1/4. 2 times negative 1 is what? Negative 2 plus 1 is? Negative 1. What is negative 1 to the 1/2?
Negative 1.
It's going to be the square root of negative 1. All right, let's look at the next one. 3 times negative 1 is... Yeah, what's the problem? We're talking about real numbers. This is the square root of -1. Can you do that with real numbers? -1 is not a solution. So my only solution here is positive 3/4. Positive 3/4.